The topic is understanding the concept of customize. I will explain you the definition and theory of the customize and a practical project in which I will be implementing the concept explained in this theory part. So let's begin. First, let's understand what is the definition of customize. So customize is an open source template free configuration management tool for Kubernetes that allows you to define and manage applications resources natively. Instead of introducing a complex templating language like Helm, it uses a purely declarative plain YAML approach to customize and layer environment specific configuration options without altering the original files. Basically, when we implement the concept of Helm, we are certainly providing or using more effort in preparing the YAML files, even though we are thinking that we are only doing it for once. In short, even if we deny, we are still preparing the template folder by preparing the YAML files in Helm, which means we are providing a little more effort to prepare the repository or whatever. But Helm has its own benefits. For package management, it can be great, but with respect to only manipulation of YAML files, with respect to environments like production, development, or base, there comes the concept of customize, where we don't need complex configuration like Go language to prepare the deployment files, which is the case in Helm. In Kustomize, we don't need templates, and it's a configuration management tool which allows us to define and manage application resources natively. So irrespective of Helm, which has Go language templates or YAML files which are complex to prepare it for once, in Kustomize, it is purely a declarative plain YAML approach to customize and layer environment specific configuration options without altering the original files. This is just a definition. You will understand it better when I explain you in the tutorial or practical part later in this video. That was the definition. Now let's understand the core concepts in Kustomize. First is base. Base is a directory containing raw Kubernetes manifest. For example, deployment YAML file, service YAML file, and every YAML file which you prepare to run your application. And also it contains a additional YAML file that is kustomization.yaml. That kustomization.yaml file represents the single source of truth for standard generic settings. Next is overlay. This is a separate directory containing a kustomization.yaml file that refers to the base which we just created before overlay. Overlays define target environment variations such as development, staging, or production, and patch specific fields on top of the base. Third is kustomization.yaml file. This is a central configuration file that lists resource fields, references bases, and instructs Kustomize on how to transform the manifest files. That sounds too complicated, but I'll explain you in a simple way. Kustomize has the concept which is base, overlay, and kustomization.yaml files. These three are the core concepts. First is base. Base is just a folder in Kustomization where you keep your deployment or all the YAML files which you have already created. Meaning, if suppose you have at least deployed one application or by performing Kubernetes concept of YAML files or whatever. If you have watched my other videos where I have implemented tons of projects with respect to Kubernetes, even if you have done one of those projects in your own application, then you would have certain YAML files that is already present in your folder. So that YAML files would be considered as the base inside the base folder. On top of that, there exists another YAML file that is kustomization.yaml file. I will explain kustomization.yaml file in a bit, and that was about base. Now let's understand what is overlay. Overlay is the same as base. It is another folder that is named as overlays, but instead of having all the YAML files present which was in the base, it doesn't have those YAML files. It only has customization of YAML file and the YAML files which you want additionally for patching or changes you want to see from the base configuration. Meaning, if you are not happy with the base configuration and you want to have certain replicas or whatever you want to change, you specify that specific YAML file by creating a patch YAML file inside the overlay folder, by creating a development production environment folder, and inside that you can define another YAML file with patching of the replicas. And if you want some more changes like for service ports change or changing of like load balancer or cluster IP or node port, whatever, you can create another YAML file to change from base to the overlay of the development folder. I hope you get the point. And you can create another overlay inside the overlays folder, meaning that was our dev, and you can create another staging folder in which you can specify more changes into the base folder. So simply base folder is the reference point where you provide changes in the staging folder, and you have kustomization.yaml file that references that you are using which YAML file from the base folder. I hope you get the point. So overlays will be having folders that would be naming development, staging or production, and you will define the YAML files with respect to the change you want in your deployment or services. You will understand it better when I will show you the practical session. It will be really simple when I do that. But as of now, you can understand this as a theory concept. Third is kustomization.yaml file. This is a central configuration file in which we list the resource fields, reference bases, and instruct Kustomize on how to transform the manifest. Simply in the base folder, there exists kustomization.yaml file in which we define all the resources we are specifying in the base folder. Meaning if you have added deployment, service, configuration, ingress, YAML files, you will specify those in the customization by mentioning that you have these in your base folder. So that was about definition and understanding what is base, overlay, and customization.yaml file. But I can explain you in a better way by giving you an example. Meaning you can imagine how a professional painter paints. Meaning they would not entirely paint on a single sheet of paper and consider that as their original or end product of their painting. A professional painter would paint in a way that is, first they would create an outline of their painting that would serve as a base. So they would be creating outline in a single page that would be the base of the painting, and next they would be using another sheet of paper above it that would act as an overlay. So they would enhance that base in the next paper by using base as a reference point to enhance the painting. And they can also add a next paper above that second paper of overlay, so they can enhance the painting even more. That is the simplest analogy I can give for you to understand the concept of Kustomize. We are using base as a base configuration to enhance or customize our application with respect to the environment, that is development, staging or production, by creating a folder named overlays where we use base configuration YAML files as a reference point to update or enhance or change the configuration by providing or creating new YAML files and referencing those base YAML files in the customization YAML file and adding the patches inside it. I hope you get the point. You will understand it better when I show you in the practicals. But that was about the theory part of understanding what is customized and definition, key features, core concept, and analogy. With respect to my application, that is multi-tier database, front-end, back-end, Node.js application, that is Resumatcher, I first created a customize folder. Inside that customize folder, I created another folder that is base. Inside that folder, I pasted YAML files which I already had from my previous working deployment of the application. Meaning if you already have the deployment YAML files of your previous deployments, you can simply paste those all working YAML files inside the base folder. I did the same. I added all these. Apart from adding all these YAML files, I also created a new YAML file that is kustomization.yaml file. You can observe in this YAML file of customization, it has API version kustomize.config.kts.io/v1 beta 1. The kind is customization. Resources, as I mentioned, we will specify the resources which we are using, or at least what we have mentioned inside or what we have added inside the base configuration files. As we have added config map, DB secret, Google API secret, Google CX ID secret, Postgres PVC, Resumatcher, GeoCR, service YAML. And as I've added all these YAML configuration files inside the base folder, I need to specify them inside the resources of the customization YAML file. Here, Resumatcher GeoCR is the deployment YAML file. That's it. We have created the configurations which we need to create. This is a basic configuration. You can enhance it even more by adding more details which you can find in the official documentation of Kustomize. As of now, I only needed these to perform the task which I intended or needed to do. So next is to perform the command. I performed kubectl customize./base. You can see the YAML configuration of all our YAML files. Then the command is kubectl apply -k base. You can notice that we have not mentioned -f, which we usually do while performing kubectl. When we perform Kustomize, we change the command from F to K. So the command would be kubectl apply -k./base. So we are applying the base folder. It was successful. As you can see, everything is configured or unchanged, meaning it is configured or applied. After applying, we can confirm it by the command kubectl get pods -w. We can observe that all pods are up and running. This is the default configuration of my application, meaning I had the default configuration in the base folder of having 2 pods for deployment and 1 pod for DB. After I observe all pods are running, I perform the command kubectl port forward service resume-matcher GSCR service on the ports 3000, meaning the application will now run on the local host 3000. Also, one more thing to notice here is that the deployment configuration or service of the application in the base is node port, not cluster IP. Usually when we perform port forward, we do it if the service is of the type cluster IP. But if it is on the service type node port, the application would simply run when the pods are running. If it is on the service type cluster IP, you need to perform port forward command to run the application on the specified ports. When the service type is of node port, it will always run when the pods are running on the specified ports of your application deployment file. But my application was of node port, but still I performed the port forward. So I performed the port forward, and after I uploaded the resume, the results are visible, meaning the application is up and running. We can observe the logs of our base configuration. Application is up and running. We can see the Google API key is loaded and all the embedding and backend stuff is also working. So that means our base configuration is configured and our application is healthy and running on the base configuration. That is a great, but that is the base configuration. Now we need to perform overlays concept where we can create development production environment, meaning we create development folder. We can create production folder, which will have certain changes, patches by referencing to the base configuration. Let me explain that with an example. Now you can see that I have created the new folder inside the Kustomize. So Kustomize is a root folder. It will have base with those configuration, and Kustomize will also have overlays folder, which will have another folder that is development, that is dev. Inside that dev folder, I have created deployment patch YAML, customization YAML, service patch YAML file. Here deployment patch and service patch is the changes which I want to have or which I intend to have from the base configuration. So meaning the scenario would be like I am not certainly convinced with the base configuration and I want to change it right now. So I have to change it by referencing those in the customization YAML files and the changes which I want. I want change in the deployment patch and service patch. So I want change in deployment and service. So I will create these 2 YAML files with customization YAML files. We can observe the deployment patch YAML file. So this is the deployment patch YAML file. The API version is app/v1, kind is deployment. The metadata and the name is resume-matcher GSCR, namespace it's default. The change I want is with respect to replicas. Previously it was 2 replicas, now I want only 1 replicas. And image pool secret is GSCR secret, meaning I have a private image repository GSCR. I will create a secret and access that image from the GSCR. As you can see, the image is from the GSCR Kevamadan resume-matcher DevOps latest, which is private GSCR in the GitHub container registry, and I have specified the resources that this deployment should use, that is CPU, memory, LAN limits. That is about the deployment patch. You would assume that this looks like the usual lengthy deployment YAML file. It doesn't look like we are doing something really effortless. But let me explain you. This is not a complex YAML file. The actual YAML file of my application, which is in the base folder, has even more information mentioned here. So this is just a reference point with a change I want to see in the replica set. So I only want 1 replicas in the development environment. Next is service patch YAML file. Here I defined that API version version is version 1, kind is service. I want change in the service configuration. So metadata would be resume matches service name, and selector is resume matches GSCR. Type is cluster IP. Ports is defined same as it is defined in the service YAML file. Here the thing to notice is that, as I mentioned, base configuration had the service type of node port. Here I want to have a change in the service type, so I changed it from node port to cluster IP in the development of overlays. And this is the customization YAML file. The kind is customization. Resources, it is referencing to the folder of base, that is //base. Patches means changes which I want to see. Target, kind, that is service name, resume matches service. Patch, with respect to the configuration of patch segment, I have not used basic strategic merge patch, which is usually used while performing customize, because the change I want to see in the overlays development environment from the base configuration is kind of complex, like changing the port or service type, which is kind of like a immutable feed that has the potential to break the logic or to not let it work. So to prevent that, I have created patches segment for only the service patch by using the concept of JSON6902 patches. So these patches has the standard for replacing, adding, removing, moving, copying, testing, where replace will override the value at given JSON pointer path. Add will insert a new value at the specified path. Remove will delete the specified key or the element. Move, copy, or test. These are other supported benefits or operations to shift the values, copying the path and verifying the existence. We can use JSON6902 patch when we are performing immutable or logic where the application can break. So I had to use this JSON6902 patch with respect to the service cluster IP change. So I performed the configuration by OP replace. I want to replace it with cluster IP. Previously in the base it is node port. I want to change it with cluster IP, and OP replace. It is a path, that is selector. Selector is resume matches GSCR, which is same. Simply we are specifying or hard coding these values in the development. Resume matches GSCR is the same in the base, but we are still specifying so the application doesn't break. And we are performing OP replace. It's the same values as the base. So the application is hard-coded and has the basic configuration files intact, so the application runs. That was about the service configuration by using JSON6902 patch. With respect to deployment, increasing the replicas to 1 from 2, I have implemented the basic usual strategic merge patch, meaning usually we would be using this patch, and when certain configurations are immutable that can break the logic, then we switch into the JSON6902 patch. Now for deployment patch, I have specified path, that is deployment-patch.yaml. Target is kind deployment. I want to have change in the deployment, and the name is resume matches GSCR. For basic strategic patch, we don't specify the immutable or changes which we want to see in the customization YAML file. We just reference the YAML file that has the configuration details. As my deployment patch YAML file has the configurations of change, that is one replica set, I have patched or created a patches with the path, it's specifying the path, that is deployment patch YAML file. Target, that is deployment, I want change in the deployment, so it is a deployment. The name is resume matches GSCR. So that is the customization YAML file of development environment inside the overlays. As we have prepared these YAML files, now it's just a simple job to apply and run our application. Next is to apply the command, that is kubectl apply -k overlays/dev, which will apply the dev configuration YAML files. Now one thing to notice here is that we haven't specified DB secret YAML file, APIs key YAML file, CXID, Postgres. All these YAML files we haven't specified in the overlays dev folder. As I've shown you, we only had a patch for deployment and patch for service type and customization YAML file. But still we are seeing changes or configurations in overall YAML files to run our application. Meaning, as we have referenced our base YAML file configurations, the customization YAML file, so it is referencing all those information from the base and only patching or changing what we have only specified in the deployment patch and service patch, and details we have specified in the kustomization.yaml file. So it will use all the information, all the configuration from the base configuration YAML files of base folder, and only apply the patch change which we have specified in the development folder YAML files. I confirmed it with kubectl get pods. Pods are running, and we can observe that only one pod is running for resume GSCR, meaning previously it was 2 pods or base or default configuration YAML file. Now it's only one pod that is running on the deployment side, meaning our patch has worked. We have changed the replicas from 2 to 1 and it is successful. I confirmed it with the command kubectl get deploy resume GSCR. We can observe that only a single pod deployment is running. I wanted to check the services to see if it is running on cluster IP, which we applied the change for. So I performed the command kubectl get svc, meaning kubectl get services. We can observe that resume service is now of the service type cluster IP, not default, that was node port. So our change for node port to cluster IP was also successful. Now I wanted to confirm the endpoints of that service, resume service. I performed the command kubectl get endpoints resume service. We can observe that endpoints are also visible and available, meaning we can now perform the port forward to access our application on localhost. Then I perform the port forward command, that is kubectl port forward service / resume service. Ports are 3100 mapped to 3000. The application would run on the port 3100. I head back into the local host 3100 and I uploaded the resume. We can observe that the results are available with respect to the resume, meaning the application is successfully running without breaking anything. I confirmed it with the logs of the pod. We can observe that the application is successfully running with all this embedded or backend information available in the logs of the application pod. So that was about the bare overlays development environment. Now we can also create another environment as we wish. If you want staging environment, and you can create another patch base referencing to the base configuration and the change you want to see. Now I wanted to create a production environment patch. So I head back into the overlays folder, which already had development deployment files of before. Then I created another production folder, that is prod, inside the overlays folder. This also has the customization YAML file, deployment patch YAML file, service patch YAML file, meaning YAML file has the same name, but the configuration will be different here in the production environment. Now, with respect to the deployment patch, I only wanted to change from the replicas 1 to 3. For the base configuration, it is 2, and for development overlays, it is 1, and for production, I wanted it to have 3 replicas and increase in the memory CPU. Other than that, all the details of the configuration is same. Then for change in the service type, I wanted it to have the service type load balancer. In the base configuration, it is node port. In the development environment, it is cluster IP. And for production, I wanted it to have load balancer service type. Rest the configuration is same as development. Then customization YAML file is still the same. I only changed it with the value load balancer. Previously it was cluster IP, and everything is same. So now by default, Kubernetes in Docker, that is kind, doesn't support the endpoints for service type load balancer. So now in order to have service type load balancer active, or at least mimicking the service type load balancer, we must create namespace and install MetalB. So MetalB is simply an open source network load balancer implementation designed specifically for bare metal Kubernetes cluster. So when we run Kubernetes on public cloud providers like AWS, Azure, GCP, the cloud provider automatically provisions or provides us with a network load balancer type when we deploy a service of load balancer. However, an on-premise or bare metal environment, or simply in our case that is kind, or if you are using Minikube, this native automated integration, that is load balancer service type, is missing. That will leave our services stuck in the pending state. So MetalB solves this exact issue by integrating directly with our standard local networking equipment. Simply it will provide the service type load balancer. To perform that, I perform the command kubectl create namespace MetalB system. So it created the namespace MetalB system, and I installed the MetalB by performing kubectl apply -f, with the path of installing the metal B. You can use the same command to install and perform the metal B. It was successful and configured. So next was to confirm the network of kind subnet. I performed the Docker network inspect kind with respect to subnet. So I was getting the information with respect to the subnet name. Now I had to create another YAML file for metal B configuration. So I have not created this YAML file on the Kustomize folder. I created this in the main or the ultimate root folder that was resume-DevOps. Resume-DevOps had the folder Kustomize where we performed all of the before configuration and folders. But to perform or configure metal B, I head back into the root that is resume-DevOps and I created a new folder that is cluster add-ons. Inside that I created the configuration YAML file of metal B config YAML. Now as we can observe, this YAML file, it has the API version with respect to the metalb.io v1 beta 1. Kind is IP address pool metadata that is referencing to the namespace that is not default. It is metal B system which we just created. Name is kind pool. Specification, we have specified the address. API version metalb.io, same. Kind is L2 advertisement. Metadata referencing your namespace metal B system. Name is kind advertisement. Specification is IP address pools kind pool. You can also use this same YAML file if you want to configure. Or there are other configuration templates available with respect to metal B. You can also use those YAML configuration of metal B. You don't need to scratch your head around how to create this YAML files. You can get all those templates and references to prepare this configuration YAML file, which is not so complex if you use Google search and these templates available on the official documentation. So I perform the command kubectl apply -f with respect to the configuration metal B config.yaml inside the cluster add-on folder. It was successful and it created IP address pool metalb.io kind pool and it created advertisement metalb.io kind advertisement. Now, since we have successfully created or built our own service type load balancer using metal B and its configuration YAML files, we can now apply our overlays production folder. Now I head back into the Kustomize folder again and I perform the command that is kubectl apply -k overlays production. Now again, it referenced to the base configuration of the Kustomize base folder and it used all the other configurations of base and also configured our new or patched deployment and service YAML files and customization YAML files. I confirmed the number of replicas of resume deployment pod. I perform the command kubectl get deploy resume GSER. We can observe that it is not 2, it is not 1, it is 3 and 3 replicas are up and ready, meaning our deployment patch worked. Now I wanted to confirm the service type change. It should be load balancer. I performed kubectl get services by performing kubectl get SVC. As we can observe, resume service is now of service type load balancer. Previously it was cluster IP. By default it was node port. Now I wanted to confirm the endpoints to access it on the port forward. I performed the command kubectl get endpoints resume service and the endpoints were available. So that means I can access the application by port forward. Then I perform the kubectl port forward service / resume service with the ports 3100 map to 3000, meaning the application will now run on the local host 3100. Then I head back into the local host 3100 and I uploaded the resume and it was successful. The results were available with the matching jobs. I confirmed it in the logs, which means the application is healthy and up and running, which means we successfully configured production, deployment and service patch. So that was about understanding customization theory, customization concept in practical. I hope you got an idea of basic understanding at least while I explained you the concept of production, development, base, overlays and the definition core concept of customization. Summarize the video. Base configuration had replicas of 2, meaning 2 replicas or 2 pods of the deployment resume would be running and it was successful. And by default or the base configuration had the service type of node port. So to change it, to create a patch or to have change in the development overlays, we performed or created deployment patch and service type patch and we performed and we aimed for the change in those areas, meaning we wanted to change deployment from 2 to 1 and from service type node port to cluster IP, and we were successful in doing that. An application was up and running with respect to development overlays. Then with respect to production overlays, our aim was to change from base configuration that was node port into the service type load balancer. We installed and created configuration of Metal B to have the service type load balancer, which is inherently or by default missing in a kind or minikube environments. And we performed the change in the deployment of the replicas from by default base configuration that was 2. We wanted to have 3 and increased memory and CPU capacity as it is a production environment. We were successful after we performed the apply command and the application was up and running. So by default it was node port. We changed it to cluster IP in the development environment and we changed it to a load balancer in the production environment, and we have changed the replica set. So that was about the concept of customization, theory and practical. I hope the lesson and this concept was insightful to you. Thanks so much for watching. Have a great day. Bye.